interaction of light with matter can occur in three different ways. One being stimulated absorption, second one being spontaneous emission, and third one being stimulated emission. Let's see the details of stimulated emission here, which was proposed by Albert Einstein in the year 1917 as a third possibility for maintaining equilibrium between states. In stimulated emission, an atom in the excited state need not wait for the spontaneous emission to occur. Before that, it can make a transition. It may interact with a photon of energy h nu, which is given by E2 minus E1, where E1 and E2 are the energy of the lower state and the upper state. So the photon is said to stimulate or induce the excited atom to emit a photon of energy h nu. In this figure, you can see that the atom is already in the excited state, denoted by the red red color. A photon falls on this atom and it makes a downward transition by emitting another photon in addition to the incident photon. So in effect, here we get two photons from one incident photon. So this reaction may be denoted as A star. Here A star means the atom is already in the excited state. So A star plus an incident photon gives back the atom A plus 2 h nu. So here the passing photon does not disappear, and in addition to it there is a second photon emitted by the excited atom. So the phenomenon of forced photon emission by an excited atom due to an external agency is called stimulated emission or induced emission. Now let's see the probability for this reaction to occur. The probability of stimulated transition is given as P21. 21 is given as subscript indicating that the transition is from the second level to the first level. So that is proportional to rho of nu. And we may write that as equal to B21 into rho of nu. Here B21 is a constant of proportionality and that is known as Einstein coefficient for stimulated emission. So that is a constant characteristic of the atom and represent the property of the energy states E1 and E2. So it actually represents the probability of induced transition from 2 to 1. Now let's see the rate of this stimulated emission of photon. So the rate will be given by B21 into rho nu into N2, N2 being the number of atoms in the excited energy level. So going to the features of this process, first and foremost, it is controllable from outside. Second feature being photon induced in the process propagate in the same direction as that of the stimulated photon. So this will be very important in the making of a laser, this property. Third feature is the induced photon has features identical to that of the inducing photon, and it has the same frequency, phase as well as a plane of polarization for the stimulating photon. Then multiplication of photon, we have already seen that one incident photon results in two photons here. When these two photons emerges, they will be traveling in the same direction, interact with two more excited atoms and generate another two more photon. So making it a total of 4 photons. These 4 photons in turn stimulate another 4 excited atoms and generate 8 photons, and this process goes on. So the number of photons builds up like an avalanche model. And finally, light amplification occurs here because we have a single or initial wave here, and we get an avalanche of photons, and all the waves are in phase, giving a light amplification. So these were the ideas regarding stimulated emission or induced emission process.